Now, here is the very first method to split the dataset into different folds, and this is called as KFold. Uh, K indicates the number of folds that are needed. So in this particular plot that's copied from the Scikit-learn docs, here we can see there are 4 folds, fold 1, 2, and 4. X-axis, we have the sample index. Y-axis, cross-validation iteration. So the first iteration, this was the split. This is how the split was done. 4 folds were made. So dataset, trained dataset was divided into 4 different sets of equal sizes, and the first set was assigned as a test set. The next remaining 3 sets were assigned as a train set. The model was trained on these remaining 3 sets in that first iteration, and then in the second iteration the first set was merged back as a train set, and the second set was changed into a test set. So this second iteration, the training was done on fold 1, 3, and 4, shown here by blue. And here the test set is shown by orange. So here there are 4 iterations. Now down below, just to understand what this image is showing, we have 2 different colored lines. Class indicates the class, that's the target class. So it could be 0 for this light blue, 1 for this light orange, and then 2 for dark brown. So we have 0, 1, 2, 3 classes. There is also additional row here which is groups. So the groups are not used in this particular explanation, but they'll come up soon. The groups is just an addition. You can think of it as an additional class uh, that is in the dataset. So, for example, if you have a dataset for um, let's say harvesting of apples, so you have the fruits in one column, apples, oranges, etc. So that could be the class here, and then groups could be the city in which those were cultivated. So maybe city A, city B, city. So those are the additional groupings that dataset. And here rest is the same. So KFold is not affected by classes or groups, but what it means is that we use the KFold cross-validation KFold method for creating folds on the trained dataset. Then as you can see here, one of the issues is in this particular fold, for example, you can see that all of the blue colored class is there in the test dataset, but it's not there in the train set. And similarly, in this case, the test set does not have the blue color class. So that's something to remember when using the KFold method. Here is the code for that. So let's say we have this array which is shown here on the right hand side. We have 4 rows and 2 columns, so 2 features and 4 records. We perform the K-fold split. So the code is very simple. Kf is the variable is equal to K, capital F, fold, and then we have number of splits is equal to 2. So as you can see down below here, we have the 2 splits. The first one is 3, 2, 4, 5. So 3, 4, 5. And then the second split, and this on the square bracket, this is showing the index. So index 2 and index 3. So 0, 1, 2, that's the first index, and 3 is this index. So these bottom 2 records are selected first for training. I'm not showing the test array here, but if you run this code, you'll see the test as well. Then in the second iteration, 0, 1 indices are picked. So 0, 1, that's 1, 1, and 2, 4. So those would be the train set, and the rest of it would be the test for that iteration during cross validation. Now, there is also a method called RepeatedKFold. Now, RepeatedKFold is similar to KFold, except as the name suggests, the process is repeated. So here the method for implementation is the same as we saw earlier. RKF is the variable is equal to repeated k-fold, number of splits and number of repeats. So this is the additional argument that we passed to the method. And as you can see on the right hand side, we have this matrix here. The first split is 1 3, so 1 1, and then 0 1 2 4 5. Sorry, 2 4 and 4 5. So that's what we have. Then we have second, third and fourth split, uh, first and second. So that's done here, and then this is the second repeat using the repeated k-fold. Now, in addition to repeated k-fold, there is a method called repeated stratified k-fold. What stratified means here is that, let's say if you have three, if you have, let's say 10% of the records belong to class 0 and 90% of the records belong to class 1, and the data set has just two classes. Now, when you perform the split, as you saw earlier, it can happen that uh, the trained data misses out on the other class, that is a minority class. And so what stratified does, it tries to preserve the percent or proportion of each of the classes in both the train and the test data set. So that's the idea behind repeated k-fold. Now moving on, let's look at LeaveOneOut method. So this is a very simple method. The idea is shown here. Let's say we have this data set that has 4 records and 2 columns, so 2 features. When we split this data set using the LeaveOneOut method, what is done is we are leaving, let's say, the first record for the test set, and then we put everything else as a train set. Then in the second iteration, we pick another record, set it aside as a test set, and then remaining data set can be used as a train set. So that's the idea behind this method. And according to the docs, as a general rule, 5, because this can be memory intensive, 5 or 10-fold cross validation should be preferred to this method. And here is the implementation for LeaveOneOut. On the right hand here we can see the method is pretty standard. LOO, that's the variable, and then we have LeaveOneOut, open close parenthesis, and that gives us the splits for this particular method. And right hand side we can see that this is our original data set, and here we have the indices 1 2 and 3. So in the very first iteration, the record at index 0 is set aside as a test set, and the remaining 1 2 and 3 records at those indices are considered for the train set. The second iteration, the index 0 set is retained for train, whereas the index 1 record at index 1 is set aside for the test set, and so on for the remaining indices. Similar to LeaveOneOut, there is LeavePOut method as well. Now in this method, as you probably guessed, we can specify how many number of records should be left out for the test set, and the process goes the same way. So in the first iteration, let's say if we specify p is equal to 2, then we leave the records at the first 2 indices for the test set, and then the remaining data, in this case just 2 records, those are used for the train set. So these 2 are for train, those 2 are for the test set. The code is pretty straightforward. Here we specify variable LPO is equal to leave p out, so we can specify the number of the value for p. Here it is 2, and on the right hand side now we can see that this particular data set of 4 rows and 2 columns is split in different folds as shown here. So the first case is indices 2 and 3 are the records at indices 2 and 3 are assigned to the train set. So we have indices 2 and 3, so 3 2 4 5, and the rest is assigned for the test set, and so on for the remaining records right here. Now moving on, let's look at shuffle and split. As seen here, the idea with shuffle and split is that first the samples are shuffled and only after that they are split into train and test sets. So it's here what you want to keep in mind is that uh, step of shuffling the data set going to affect the train data. For example, if you have sequential data that needs to be maintained in a sequential form for the model to train on, then you probably don't want to use shuffle. But if that's not the case, then this is the method and this is how it works. So in the first case, we have the indices 1 and 0, they are assigned to the train set. So 1 and 0. So we have 2 4 and 1 1. So that's here. In the second iteration, 2 and 1 are assigned to the train set and the remaining for the test set. So for 2 1, so we have 0 1 2 3 2 and 1, so that's 2 4. So those two are assigned there, and so on for the um, next iteration as well. So here if we look at the plot again, this is from the copied from the Scikit-learn docs, and it's a really good example to show how the shuffle split works. We have 4 different iterations. The lines here shown in the dark orange, those are for the test set. The blue is the data for the train set. And in the very first iteration, we can see that the data is the data is randomly uh, selected for testing, as you can, and the training set. So it's not a continuous chunk of data as we saw in earlier cases. Rather, it is a few records from this place, few records here, and few records at this index. So that's how the shuffle and split works. And again, the process of picking the records for the train and test set is random. So in each of the 4 iterations, we can see that different records have been selected. There could be a repetition, but for most part, it's random. And again, in this case, the chance that all the 3 classes are represented in the either the train set or the test set could be little better, but still, as we can see in the last case here, none of the test data set has this particular class with light blue color. All of them are either this light orange or dark orange. The code for implementing shuffle split is shown here. We have a shuffle split, and within parentheses we're specifying n underscore splits is equal to 3. So 3 splits and the test size is 0.30. And accordingly then we can get these 3 splits that are shown here. These are the indices for this, right? So index 1, that is 2 4, that's right here. Index 0, which is 1 1, that's right here. That's the train set. The test set is not shown here, but if you run this code again, you will be able to see the test set as well. Now looking at stratified K-fold, this is a variation of the K-fold methods that we saw earlier, and here the stratified K-fold approach, what it does is it maintains the proportion of each class within the train set and the test set. So it keeps the proportion the same in both. So here we can see that these dark orange boxes, those are the train sets. So uh, bits of each of the class are chosen for each iteration. So there, as we saw before, in some cases, one of the classes was not present in the test set, but in this case, all the classes are present in both the train and test set. And not only that, the the proportion is also maintained, and it's more or less the same in both cases. So let's say if you have 10% of class 0 in the train set, then the test set would also have 10% of class 0. Here is the implementation for that. The variable SKF stores the information for stratified K-fold, capital K, capital F. Number of splits is specified as 3, and then we can, from this we get the indices, and with those indices we can get the values, the records from the X and Y for the train and test. Here we can see the records for Y train, and both from stratified K-fold and just simple K-fold. Yeah, on the top we can see that there are two classes, 0 and 1, and in the train set both the classes have the same proportion, similar proportion, not same but they're close, 3 and 5, 3 and 5, and this is identical 4 and 4. Whereas in K-fold the proportions vary a lot. Here there is 1 7, so there's just one record from class 0, and then rest of them are from uh, class 1. So others are closer to this, but if you, this is a very small data set. If you look at the same code on a much larger data set, you'll be able to see the difference very clearly. Now, in addition to shuffle split that we saw earlier, there is also stratified shuffle split. Again, the objective here is the same. You want to maintain the proportion or percentages of number of records in each class in both the train and the test set, and that's exactly what is achieved here. Again, we can see that all the classes are represented in each of the splits, so there is no split that is missing either of these three classes shown down here. So that's the idea behind stratified shuffle split.